So, in the earlier class under Ionic equilibrium, we have started to discuss about pH. Under Ionic equilibrium, we have started to discuss about pH, how to calculate pH of strong acid, strong base, weak acid, weak base, and then if normality, if concentration is given normality or molarity, all those things we have discussed. Now let us go into few example sums and evaluate yourself sums given in your book. All right. So pH, very first example, 8.2. 8.2. It is for the calculation of pH of 0.001 molar HCl. That's what I think. pH of 0.001 molar HCl. How to calculate pH? Whenever pH is given as decimal number, convert it into a one-digit number. 1 into 10 power minus 3. Mole per decimeter cube, of course, or mole per liter, whatever it may be. So, concentration of pH of this solution is asked. pH of this solution is asked. So, concentration of hydronium ions. It is a strong acid. It ionizes fully. If 1 mole gets ionized, you will be getting 1 mole of hydrogen ion and 1 mole of chloride ion. You will be getting 1 mole of hydrogen ion and 1 mole of chloride ion. Since we are getting 0.001 molar HCl, it should give 0.001 molar hydrogen ion and 0.001 molar chloride ion. Of course, hydrogen ion exists in the form of hydronium ion. That also we know. So, hydronium ion concentration is equal to this much. Same thing. Concentration is not 2 less. 2 less means of the order of 10 power minus 6, minus 7, minus 8. If it goes like that, we have to take into consideration the concentration of hydrogen ion produced from water. Now it is not needed. All right. So, concentration of hydronium ion we know. Based upon that, we can calculate pH. pH is equal to minus log to the base 10 of hydrogen ion concentration, minus log hydronium ion concentration. That is pH. All right. So, minus log 10 power 1 into 10 power minus 3 or simply 10 power minus 3, both are same, which is equal to minus log 1 minus log 10 power minus 3. How? Log A into B becomes log A plus log B. Since minus sign is there, it is common for both 1 as well as 10 power minus 3. Therefore, I made minus log 1 plus of minus of plus log 10 power minus 3, whatever it may be. We know the value of log 1 is equal to 0. Characteristic 0, one digit number 0, 0.000 it will come. So, it is 0. When minus 3 comes front, it will become plus 3 log 10. So, here the formula that is applied is log x y is equal to log x plus y, log x plus log y, that is what I written. If we have minus like that, minus log x minus log y, that is what I adapted here. And then here log a power x or x power a, whatever it may be, log x power a is equal to a log x. Here it is minus log x power minus a, something like that. So that I have used minus into minus plus a log x. In that way I have written. Hope you understood. So 3 log 10. Log 10 value, what is the value of log 10? It is 1.000 it comes. So 1 into 3, 3. So simply on looking at it, I can find out it is 3. It will give 0, it will give 3. So log pH is equal to 3. Since it is the first time I have introduced all these steps, on looking at the concentration, you can find out pH is equal to 3. All right. That is example 8.2. And then what about next example? Let me go into the next example. pH of 10 power minus molar HCl. pH of 10 power minus 8 molar HCl. It is very low concentration. minus 6, minus 7, minus 8 is of very low concentration. If it is 10 power minus 8 molar, how to calculate? Hydrochloric acid, as I said earlier, it ionizes in water to give H plus ion and chloride ion. 10 power minus 8 should give 10 power minus 8 and 10 power minus 8. Of course, chloride ion is not at all associated with acidic nature. Therefore, we won't consider only hydrogen ion stands for acidic nature of acid. But it is very low. If the concentration seems to be very low, like 10 power minus 6, 10 power minus 7, 10 power minus 8, like that, what we have to do? We have to take into the consideration of hydronium ions available from water. Water upon ionization produces hydronium ion and hydroxide ion. Hydronium ion concentration 10 power minus 7, 10 power minus 7. Neutral solution ionizes only slightly. How much get ionized? Out of 1 mole, maybe 10 power minus 7 get ionized to give 10 power minus 7 mole per liter of hydrogen ion, 10 power minus 7 mole per liter of hydroxide ion. Now we are going to count the total concentration of hydronium ions to get pH. We want to get pH, therefore hydronium ion concentration we are considering. Since the concentration of hydrochloric hydrogen ions available from hydrochloric acid very, very less, that is 0.00000. 1, 2, 3, 4, 5, 6, 7, and then 1. That is 10 power minus 8. 1, 2, 3, 4, 5, 6, 7, 8. Since it seems to be very, very less, the pH will come to 8. But acid cannot have pH 8. It should have pH less than 7. Therefore, concentration of hydrogen ions available from water is also considered. That also plays important. The role played by hydrogen ion is important here because it is very, very less. The addition of this concentration only will lead to acidic nature, and therefore that has to be added. It is 0.000001. If I add, it will get 0.0000011. So that is the concentration of, total concentration of hydrogen ions available from this concentration of aqueous solution. It cannot be neglected since it seems to be very, very small. Suppose if I have excess, I need not consider. But I have very, very little concentration of hydrogen ions. The concentration of hydrogen ion from water should also be considered, and therefore it becomes like that. What will be the value? 1, 2, 3, 4, 5, 6, 7. 1.1 in 10 power minus 7 total. If I add the two, I should get 1.1 in 10 power minus 7. But writing like this, it may be a work of primary students, and we can slightly do the work in another way. Concentration of hydronium ions is equal to 10 power minus 8 or 1 in 10 power minus 8 plus 1 in 10 power minus 7. Concentration of total concentration of hydronium ion concentration is equal to concentration of hydrogen ion from HCl, concentration of hydronium ion from water. If I sum up, how can I sum up? The 10 power value should be equal. How can it be made equal? I can multiply it by 10 and I can divide it by 10. Therefore, 0.1 in 10 power minus 7. I have multiplied it by 10 and I have divided by 10, 0.1. Plus 1 in 10 power minus 7. If I sum up 1.1 in 10 power minus 7, that is the hydrogen concentration. So first of all, it has to be considered. It is a mental sum. To start with, since I are introduced for the first time, I am explaining like this. Hydrogen concentration, total concentration of hydrogen ion concentration is equal to 1.1 in 10 power minus 7. Therefore, pH, what is the pH? pH is equal to minus log hydronium ion concentration, which is nothing but minus log 1.1 in 10 power minus 7, which is equal to minus log 1.1 minus log 10 power minus 7. Minus log 1.1 minus log 10 power minus 7. Now we have to know the value of logarithmic value of 1.1. That you have to refer from your class table. I don't know the value exactly. When it comes over here, it is plus 7 log 10, which is equal to plus 10. Minus log 1.1, 7 log 10, which is equal to minus log 1.1 plus 7. So definitely the value will be point something. Therefore, 7 minus something you will be getting. This is how we will be getting the pH value. All right. So the value, let me refer the book and I can write logarithmic value they might have given. But since I don't have Clark's table now, let me 4.8.3 example. Yes, the value seems to be, sorry, they have taken some other value. It is not example 8.3. I have taken some other thing. It may be, no, I have, this question is not given in the book. You just have it. You find out a logarithmic value for 1.1, it will be 0 point something, plus 7, it will be 6 point something will be the answer. All right. So pH is slightly less than 7, like you will be getting the answer. You can try. But in 8.3, they are given 10 power minus 7. Now let me go into 10 power 7. In example 8.3, they have given, calculate the pH of 10 power minus 7 molar is here. Let me go in for 10 power minus 7. 10 power minus 7. 10 power minus 7. Just I modified. Concentration of hydrogen ion available is also 10 power minus 7. So it is 10 power minus 7. Since it is of the order of 10 power minus 7, concentration of hydrogen ion available from water should also be taken into account. See if I add, what will be the value? 1 plus 1, 2. 1 plus 1, 2. So 2 in 10 power minus 7. 2 in 10 power minus 7. Therefore, instead of 1.1, 2. 2. What is the value of log 2? Of course, I know the value of log 2. It is very common, all the chemistry students should know. Log 2 is 0.3010. Because in volumetric analysis, we used to take 20 ml, using 20 ml pipette, and for log 20, it is 1.3010. For log 2, it is 0.3010. So it is 0.3010. And the value will be 6.699. So that is the pH. So for 10 power minus 7, I have calculated. For 10 power minus 8, we have arrived at log 1.1. It is slightly less than 7. That you should know. All right. So this is how problems of this kind have to be solved. And let me go into the next sum. So next sum may be, evaluate yourself. 6, calculate the pH of 10 power minus 8 molar sulfuric acid. Evaluate yourself. Under that, you are asked to find out pH of 10 power minus 8 molar sulfuric acid. Remember, it is sulfuric acid. Remember, it is given in molarity. When the concentration of sulfuric acid is given in molarity, since it furnishes 2 moles of hydrogen ions, it will give 2H3O plus SO4 2 minus. Therefore, if the concentration is 10 power minus 8, here you will be getting 2 into 10 power minus 8. Don't forget, that is more important. Earlier, I have taken 10 power minus 8 molar HCl. Therefore, I have taken as such. Now it is sulfuric acid given in molarity. 1 mole should give 2 moles of hydrogen ions because the basicity of sulfuric acid is 2. So 2 into 10 power minus 8 mole per decimeter cube. Of course, sulfate ions 10 power minus 8 only, that we are not bothering. Our interest is to find out the hydrogen ion concentration. Since it seems to be a very weak acid of the order of 10 power minus 8, concentration of hydrogen ions available from water cannot be neglected. Hydronium ion concentration plus hydroxide ion concentration. This we need only hydrogen concentration, 1 in 10 power minus 7 mole per decimeter cube, neutral solution, all water. So we have to add both concentration of hydronium ions, total concentration of hydronium ions available from 10 power minus 8 molar sulfuric acid is equal to hydronium concentration total, hydronium ion concentration available from sulfuric acid, which is hydronium available from sulfuric acid, that is from acid, from water, from acid, from water. From acid, how much? 2 in 10 power minus 8. From water, 10 power minus 7. It has to be converted to 10 power minus value. How? To convert it to 10 power minus 7, I have to multiply it by 10, it has to be divided by 10. Therefore, 0.2 in 10 power minus 7. 1 in 10 power minus 7. If I add 1.2 in 10 power minus 7, so hydrogen concentration is equal to 1.2 in 10 power minus 7. Therefore, pH is equal to minus log hydrogen ion concentration. Minus log hydrogen concentration, which is equal to minus log 1.2 in 10 power minus 7, which is nothing but minus log 1.2 minus log 10 power minus 7, which is equal to minus log 1.2 plus 7 log 10. Minus log 1.2 plus 7 log 10. Log 1.2 is nothing but minus point something plus 7. So you'll be getting the value 6 point something. You find out the logarithmic value. I don't know the value for 1.2. Log 1.2 you find out from Clark's table, substitute and you will be getting the answer. So this is how the sums have to be calculated very carefully. Same sum may not be asked in the examination. You have to be ready for everything. The next sum under evaluate yourself. Next sum under evaluate yourself. Calculate the hydrogen concentration in mole per liter of pH 5.4. pH is equal to 5.4. You are asked to find out hydronium ion concentration. That is the question. How to do the sum? Just the reverse. pH is equal to minus log hydronium ion concentration. So log hydronium ion concentration is equal to minus pH. Both sides, upon multiplying both sides by minus 1, minus pH is equal to log hydrogen concentration. Upon taking antilogarithm of log hydrogen concentration is equal to simply hydrogen concentration. Here antilog of minus pH. So this is how the formula goes that we have discussed already. Minus pH means we will be getting antilog of minus 5.4. But I have discussed this very clearly. Antilogarithm has to be calculated only for a positive number and not for negative number. When I write minus 5.4, the meaning is both 5 is minus, 0.4 is also minus. Therefore, together minus 5.4. That is the meaning. When I write minus 5.4, minus 5 and minus 4 together become minus 5.4. But antilogarithm can be taken only for a positive number. This number should be made positive after the decimal point. Antilogarithm we are taking only for the decimal point and not for this number. How to make it into positive number? Let me add 1 with 5. Therefore, it becomes 5 minus 6. Minus 6. I have added 1. And from 1 I have to subtract the decimal point. If it is subtracted, I will be getting 0.6 plus 0.6. So what I did? I have added 1 with it. I have subtracted this value from 1. What I have added, from that I am subtracting. Therefore, it becomes minus 6. The sum of the two, minus 6 and plus 0.6 will give minus 5.4. Am I correct? Minus 5 and minus 0.4 will give minus 5.4. Likewise, minus 6 and plus 0.6 will also give minus 5.4. That I am going to write here. Minus 6 and plus 6. Minus 6 and plus 0.6. How to write? Antilog of bar 6. When I write bar 6, the meaning only 6 is minus 0.6. The meaning is it is plus. That is the meaning of 6 bar 0.6. 6 bar 0.6 denotes this is minus value, this is plus value. So antilog of 6 bar 0.6. If you take antilog for the number 6, you will be getting the answer. Antilog for 6, again that has to be referred, and that you will be getting as a 1-digit number, antilog of 0.6 as a 1-digit number, and the value will be into 10 power minus 6. This value come as 10 power minus 6. This is 1-digit number, point something. All right. For 0.6, I don't know the antilogarithmic value also. So refer from your clock table so that you will be getting the answer. Hydrogen concentration is equal to. And if answer is given in the answer is not given, but I solve the answer. It comes to the antilogarithmic value is given as 3.981. It comes to 3.981. That's all. So 0.6 antilogarithm for 0.6 is 3981. You put a decimal point after 1 digit, make it into 10 power minus 6. 0.5, if I take antilogarithm, it will be 1-digit number, point something. Like this only you have to write. And the remaining, whatever it is given in 10 power minus 5 means in 10 power minus 5. Or, whatever is present here. 6 bar means 10 power minus 6. Only 6 means in 10 power 6. Like this it will come. Alright. So that you have to remember very clearly. Very clearly you have to understand. 0.6 if you take antilogarithm, get the number, make a decimal point after 1 digit into 10 power this value. Whatever the value. Minus 6 means minus 6. Minus 5 means minus 5. It is simply 5 means 10 power 5. Like this it will come. Alright. So that is about calculation of hydrogen concentration from pH. Hope you know how to calculate negative number into bar value. Now let me go into probably the last question, the evaluate yourself. Third question, little bit trickier, little bit few more concepts are also involved, and you should understand clearly, then only you can answer the question. What is that question? It is given like this. You are asked to calculate the pH of an aqueous solution obtained by mixing 50 ml of 0.2 molar HCl, 50 ml of 0.2 molar HCl with 50 ml of 0.1 molar sodium hydroxide, 50 ml of 0.1 molar sodium hydroxide. These two are mixed. Then what will be the pH of the resultant solution? That is the question. If these two are mixed, earlier we were calculating. If we calculate the pH of the solution separately, we can calculate separately. That is not the matter. But they have taken certain volume of it, and a certain volume of it is mixed with a certain volume of another base. Therefore, neutralization occurred. After neutralization, what will be the pH? That is the question. Sometimes both may be acid. If it is the case, we have to add. Here, neutralization. Therefore, we may have to subtract. Acid neutralizes base. Therefore, we have to subtract. How? Let us see. You know molarity. What is molarity? Mole per liter. Concentration of hydrogen ion. How much? It is 0.2 mole per decimeter cube or liter, whatever it may be. Mole per decimeter cube or liter, both are same. Now we have taken only 50 ml. Hydrochloric acid, 0.2 molar means it should have 0.2 mole per liter. Since we have only 50 ml, what will be the number of moles available? Out of 1000, if we have 1000 moles, if we have 1000 ml, if I have 1000 ml, these many moles are present. That is the meaning of mole per liter. 1 liter contains 1000 ml. That is 10 power minus 3, 10 power 3 ml. Mole per liter. Now we have only 50 ml. Can you understand? The meaning of 0.2 molar is 0.2 mole per liter. Mole per liter. That is mole per decimeter cube per liter means 1000 ml. So in 1000 ml we have this much mole. Therefore 50 ml how many moles will be having? How much? 50 into 2, 100. It is 10. 50 into 0.2, therefore 10. Into 10 power minus 3. These many moles are present in from this solution. Now what about sodium hydroxide? Hydroxide ion concentration. How much? 50 ml. In 50 ml we have 0.1 mole. 0.1 mole per liter. That is the meaning of 0.1 molar. 0.1 mole per liter. Out of 1000 ml we will be having 0.1 mole. Now we have only 50 ml. So 50 into 0.1 will give 5. 5 by 5 into 10 power minus 3 mole. These many moles are present with hydrogen, with sodium hydroxide. When these two are mixed, total volume will become 100 ml. In 100 ml, we will be having this much excess of hydrogen ion and this much excess of hydroxide ion. So 10 into 10 power minus 3 mole minus 5 into 10 power minus 3 mole. This is hydrogen ion, this is hydroxide ion. Neutralization, only this much will be neutralized. How much will get neutralized? 5 into 10 power minus 3 mole can neutralize 5 into 10 power minus 3. What is the remaining? That's what we are calculating, which is 5 into 10 power minus 3. 5 in 10 power minus 3 mole can neutralize 5 in 10 power minus 3. Remaining will be 5 in 10 power minus 3 mole in 10 ml. Sorry, in 100 ml. 100 ml of the mixture will have 5 in 10 power minus 3 mole of hydronium ion because it is excess. Hydronium ion is excess. 5 in 10 power minus 3 mole excess over hydroxide ion. That is the meaning. It is present in 100 ml. Therefore, what is the concentration? 5 into 10 power minus 3 mole is present in 100 ml. Therefore, in 1000 ml, how many would have been present? Because that is the concentration. Concentration of hydronium ion, concentration of hydronium ion is equal to number of moles of hydronium ion per 100 ml into 1000. Therefore, the concentration will be 5 into 10 power minus 2 mole per liter. Now it is liter. I made it as liter. All right. It is 0.1 liter. It is 1 liter. Therefore, out of 1 liter, 5 in 10 power minus 2 mole is present. That is said to be concentration. In 1 liter, how many moles present? 5 in 10 power minus 2 mole is present in 1 liter. In 0.1 liter, this much. 0.1 liter means it will be 5 in 10 power minus 1 per liter. That is hydrogen concentration. Now we have to calculate pH. So pH is equal to minus log hydronium ion concentration, which is equal to minus log 5 into 10 power minus 2, which is equal to minus log 5 minus log 10 power minus 2, which is equal to minus log 5 plus 2 log 10. 2 log 10 means 2. Log 5, I know the value of log 5. It is 0.699. 0.699. This number is also I am familiar. Number 5, 0.699. Minus 0.699 plus 2. Therefore, 1.3010. That is the pH. So with that, I think we are completing the calculation of pH. One more sum that also involves, what is it, dissociation of weak acid. That concept is also involved, and I may go into that. That is present in the next example. Let me go into that. What is that? Just one more sum. With that, we end up with different questions. Calculate the pH of example 8.5. Calculate the pH of point pH of 0.01 molar, pH of 0.01 molar, sorry, not 1, 0.1 molar acetic acid. It is a weak acid, therefore one more data we need. Dissociation constant of acetic acid is 1.8. Dissociation constant is 1.8 10 power minus 5. Usually this is the value. For that you should know the logarithmic value. So Ka is equal to 1.8 in 10 power minus 5. They are given two data. Apart from the concentration, Ka value is also given. Only then we can do the sum. How? Hydrogen concentration is equal to alpha C. That is one formula I given. Hydrogen concentration is equal to alpha C. But we know Ka is equal to alpha square C. If I substitute, instead of alpha is equal to alpha square is equal to Ka by C, therefore alpha is equal to root of Ka by C. Let me substitute here. Therefore I will be getting root of Ka by C into C. Root C, C. If I cancel out, here root C will come. Therefore root Ka into C. That's what I have given. Alpha is Ka by C. Here multiplied by C. It is root Ka, root C. Root C, C when divided by root C, it will become root C. So root Ka into C. That formula we are given. One more formula also we are given. You might have, you may be remembering. C is equal to Ka by alpha square. So you have to substitute instead of C, alpha into Ka by alpha square. Square and alpha get cancelled, therefore Ka by alpha. That is hydronium ion concentration. These are the three equations available for weak acid. Two data should be given, either alpha and C or Ka and C or Ka and alpha. Now they are given C concentration and Ka. Therefore the equation that we have to use is this one. Hydrogen concentration is equal to root of Ka into C. All these equations I have given on the other day. So hydrogen concentration is equal to root of Ka into C. Let me rub these things. Hydrogen concentration is equal to alpha root of Ka into C. What is the value of Ka? 1.8 10 to the power minus 5. What is the value of C? 10 power minus 1. 0.1 is nothing but 10 power minus 1, which is equal to root of 1.8 in 10 power minus 6. Let it be even number. Negative number, if it is even, we can take root easily. In such a manner, it has to be converted. Here there is no need, already it is in even number. Therefore, root of 1.8 into 10 power minus 3. I have taken root. It is 10 power minus 3. What is the value of root of 1.8? Root of 1.8 is root of 1.38, I think. 34. 1.34, yes. Commonly this value will be getting 1.8. Root of 1.8 very often you will be getting. Therefore 1.34 you can remember. Hydrogen concentration is this much. If hydrogen and concentration is this much, you can calculate pH. pH is equal to negative log to the base 10 of hydronium ion concentration, which is equal to minus log 1.34 in 10 power minus 3. pH is equal to minus log 1.34 minus log 10 power minus 3, which is equal to minus log 1.34 plus 3 log 10, which is 3. Therefore 2 point something will be getting answer. This is how we get the answer, and it is given as 0.1271. It is 0.1271 plus 3, 2.7229. That is answer. 1271 means, sorry, 8. 8129. So that is the pH of this solution, weak acid. For weak acid, two data we need, either Ka, C or alpha. Among the three, two data we need. Based upon that, we have to choose the equation. So with that, we complete calculation of pH. For different things, you can try. From different books, you can try. Even in our book, in a few more sums might have been given. You just go through. Thank you.